We are looking at cosine's formula today. Our focus today is on cosine's formula. If you remember, we had something on sine's formula the other day, and during that lesson, I mentioned that trigonometry as a topic or as a branch of mathematics has a lot to do with triangles, and not just right angle triangles that we have. We also have other types of triangles. You understand? When we started with trigonometry, we started with right angled triangles where we introduced SOHCAHTOA. Remember, we introduced SOHCAHTOA. You understand? We introduced SOHCAHTOA. SOHCA what? TOA. We introduced SOHCAHTOA. Yes. SOHCAHTOA is used to solve basic trigonometric ratios problem. Ratio of the sides of right-angled triangles. You understand? It is used to find what? Side of right-angled triangle, the length of the side of right-angled triangles. In some cases, you can also make use of it to solve for missing angles in right-angled triangles. But whenever a problem in trigonometry goes beyond right-angled triangles, you can no longer apply SOHCAHTOA, and that will necessitate the application of sines and cosines formulas. You understand? I remember in our last lesson, we looked at sines formula. You understand? Sines formula is a little simpler than cosines formula. Cosines formula is a little more complex than sines formula, and that is why I am not only going to show you the formula, I will show you how to derive the formula so that you will know where every variable in the formula came from. That will help you to remember the formula and know how to apply it forever. The other day we look at this. A divided by what? Sine A. You understand? Is equal to what? B divided by what? Sine B. Equal to what? C divided by what? Sine C. This is how simple sines formula is. Sines formula is telling you that in a triangle like this, you understand? In a triangle like this, where you have A, B, C, and you have your small letter A, small letter B, and small letter what? C. Sines formula is telling you that every angle, our angle is marked here. You understand? Look at our angles. Every angle is faced by a corresponding side. Look at angle A, for example. Angle A is what we mean by sine A. Angle A is faced by what? Side A. You understand? If you don't want to write small letter A, you can also write what? BC. You understand? This is side BC. Side BC is what? A. You understand? The other day I was, delivering lesson on this. I use BC. I use BC. I use AB, and I use AC instead of A, C, and B. They all mean the same thing. Either you use BC or you use A, it is talking about the length of the side that is facing the corresponding angle. So what sine formula is telling us is that when you divide the side facing angle A by angle A, the result is equal to the result you get when you divide the length of side B by what? Sine B, as in sine of angle B. You understand? It is also equal to when you divide the length of side C by the sine of angle C. That is what sine's law is telling us. And when can you apply sine's law? You can apply sine's law when you can at least find an angle. For example, if a triangle is given like this, for example, let's say angle A is given to be 60 degree, You understand? Then side A is given to be what? 7 meter. Let's put it as 7 meter. You understand? Let's say maybe side B is also given to be what? Is given to be 6 meter. You understand? As it is now, you can find the length of side C. You understand? Side C, then you can have, let's say angle C is given also to be 30 degree. You understand? Maybe angle C is given to be 30 degree. And they say you should find the length of side C. Angle C is 30 degree. They say you should find the length of what? Side C. You can simply say, A divided by what? Sine A. Sine A is equal to what? Is equal to what? C divided by what? Sine C. You understand? We are working with angle A and side A, angle C and side C. In this case, remember that our A is given, our side A is given to be what? 7 meter divided by what? Divided by what? Sine of 60 degree, because it is given, is equal to what? Our side C is not given. You can just put C because the length of the side is not given. Then you can divide it by what? Sine of 30 degree. You understand? In this case, you can see that angle A is given, side A is given. Angle C is given, but side C is not given. You can see that angle A and side A matches what is required for you to apply sine law. So what you do is you simply cross and multiply. You understand? Cross and multiply. You understand? So you're going to have sine C, sine 60C. You understand? Sine 60C is equal to what? Is equal to 7 multiplied by what? Sine of 30 degree. You understand? So in this case, you are going to make your C the subject of the formula. You understand? You're going to make your C the subject of the formula. To do that, if you look at what you have here, sine 60 here is a multiplicand. So you are going to make it a divisor on the other side. So your C will be equal to what? 7 multiplied by what? Sine of what? Sine 30. You understand? Divided by what? Sine 60 degree. You understand? So when you look for you multiply 7 by sine 30 and divide it by sine 60, it will give you the value for what? Side C. So we are not working on sine formula today. I only refresh on what we did before we are going to move towards our business of the day. So I just took our mind back to what? Sine formula that we once did. Today we are looking at cosine formula. There are some triangle problems that science law or sine formula cannot solve. Cases where you have a triangle like this, let's say A, B, and C. You understand? Let's say angle A is given to be 60 degree as usual. You understand? Angle B, let's say for example, angle B is given to be what? 30 degree, for example. Now, side C is not given, side A is not given. You understand? Now, if you look at angle B now, side B is not given. You understand? Side B is not what? Given. Side A is not what? Given. You understand? It's not given. Then angle C, which is not given, the side here is given. Let's say 7 meter here. You can see that where angle is given in this case, side is not given. Where side is given, angle is not given. You cannot apply sine formula because no particular angle and side correspond in terms of what is given and what is not given. So you have to make use of cosine formula to solve a problem in this case. So we are going to look at cosine formula. Look at C cosine formula. This is the standard cosine formula. A square is equal to b squared plus c squared minus 2bc cos what? Cos A. You understand? Remember I mentioned the other time that cosine formula is an extension of Pythagoras theorem. Look at Pythagoras theorem. Pythagoras theorem is a squared equals to what? B squared plus c squared, which is from a right angled triangle like this. You understand? A right angled triangle where you have your A here. For example, you have your B here and you have your C here. You understand? They are telling you that side A, the square of side A, you understand? The square of side A is equal to the sum of the square of side B and side B and side C. That is what they are telling you. They say A squared is equals to what? B squared plus C squared. You understand? That is the length of hypotenuse side. The square of the hypotenuse side is equal to the sum of the square of the opposite side and the hypotenuse side. If you like, we can put our theta here. If our theta is here, that means C is the opposite. Um C is the opposite, y YB is the if you put it, YB is the adjacent. This side is adjacent to the theta. You understand? That is what it means. So take for example, if our A is equals to 5 centimeter, then let's say our B is equals to what? 3 centimeter, and our C is equals to what? 4 centimeter. For example, they are telling you that the square of 5 is of the square of 3, and the square of what? 4. If we should finish the work, the square of 5 is 25. 25 is equal to the square of 3 is 9, and the square of 4 is what? 16. You understand? Look at it now. 25 9 plus 16 is what? Is 25. You understand? You can see that the square of 5 is equal to the sum of the square of 3 and the square of 4. That is what I'm trying to let us know. So cosine formula, which I have written above, is an extension of Pythagoras theorem. You understand? So looking at the cosine formula, having seen it, I'm erasing so that I will draw or sketch a scaling triangle. Cosine formula is derived using a scaling triangle. A scaling triangle is a triangle that every side of the triangle is unique. Every angle of the triangle is unique. No side is equal to another side. No angle is equal to another side. Definitely, if no two sides are equal, no two angles can also be equal. Now, let's draw a scaling triangle and try to form our cosine formula from there. Look at our scaling triangle as I try to sketch it. You understand? Okay. Okay. All right. I think this is a scaling triangle. This is good enough to be called a scaling triangle. Then we'll label A, B, and what? C. This is our scaling triangle, please remember. Now, the side facing angle B is going to be denoted with what? Small letter B. The side facing angle C will be denoted with what? Small letter C. And the side facing angle A will be denoted with what? Small letter A. Please follow as I do it. Now, you are going to draw a perpendicular height of the scaling triangle. Look at the perpendicular height. Look at the perpendicular height. You label the height as what? H. You understand? Label it as what? H. Remember, how are right angle triangles formed? Right angle triangles are formed when a vertical line is perpendicular to a horizontal line and they meet at a point. Take for example, when a vertical line like this meet a horizontal line at this point, remember a right angle is formed here. A right angle is formed here. This is what happens here. As you take the perpendicular height of our scaling triangle, the length, which is a vertical line, meet the horizontal line from A to C. You understand? Line from B meet this AC line here to form two right angles at this point. Yes, two right angles have been formed at this point. Two right angles have been formed, and by taking this perpendicular height, we have divided our scaling triangle into two what? Right angled triangles. We can decide to name this joint as D. You understand? We can decide to name it as D. Remember that the length from A to C is B, is labeled as B. You understand? But right now, we have gotten two um two triangles from this scaling triangle. You understand? We have now had the triangle A, B, D, and what? Triangle what? B, D, C. You understand? Let me follow it so that you see. A, B, D. That is A, B, D. You understand? Then B, D, C. B, D, C. We have now gotten two right angled triangles. Now, look at what we are going to do here. We are going to label um we are going to label the base length of ABD. The base length, this is the base length of ABD. ABD. This is the base length. We are going to label it as X. Yes. We are going to label it as what? As X. We'll label it as what? As X. So we'll put X here. Yes. We'll put X here. And mind you, if the entire AC is equal to is B, and then AD has been labeled as X, and they say you should find DC. You understand? To know the length of DC is for you to subtract AD from the entire AC. Remember, AC is the same as B. You understand? From A to C is the same as B now. And they have segmented it into two. We have divided AC into two. And they say you should divide it into what? Into X. And they say you should find DC. If AD is X and they say you should find DC, what you do is that since the entire AC is B, and a segment of B is X, for you to find the remaining segment of AC is for you to subtract X from what? Subtract X from B, because B is the full length of the side of the triangle. You understand? And X is another segment of it. So if you want to know the segment DC, then you should subtract X from the entire B. Then the remaining side you have is your what? DC. So if you look at it now, we have now gotten the base length of ABD is X. The base length of BDC is B minus X. Now let us try to work it out and see. I believe what I have done here is understood. X represents the length from A to D. You understand? And B minus X represents the length from D to C. All right. So what we are going to do, let's start with triangle BDC. You understand? In triangle what? BDC. You understand? In triangle BDC, what do we have? What do we have there? Remember, this is the hypotenuse side. Our hypotenuse side, which the square of hypotenuse side is equal to what? Is equal to the square of our h. Remember, this is our h here. You understand? And this is the base length. The base length now is what? The square of base length. Our base length is b minus x, and it should be in square. Remember, when you are taking the ratios, you are calculating the ratios of the length of a right angle triangle. The square of the hypotenuse side, which is a, is usually equal to the sum of the square of the remaining two sides, which are opposite and hypotenuse. We can decide to put our theta. If you put our theta here, that means our h is the opposite. You understand? But if we decide to put our theta here, that means b minus x will be our what? Opposite side. That is not our focus. So what do we have? H square plus b minus x square. Now we are going to expand the bracket. Yes, we are going to expand. Anything square means multiply by itself. So we are going to multiply this bracket by itself. So we have a squared is equals to what? H squared plus bracket b minus x multiply by itself, b minus what? X. Yeah. So our a squared will be equals to what? H squared plus, remember, b multiplied by b will give you what? B squared. You understand? You know, plus times plus is always plus. All right. So b times minus x will give us minus bx. You understand? Now, minus x times plus b will also give us minus bx. You understand? And then minus times minus will give us what? Plus. And x times x will give us what? X squared. All right. We are gradually deriving our cosine formula from a given scaling triangle. Now, what do we do? Our a squared is equal to what? H squared plus what? B squared. Remember, minus bx will give us minus 2bx. You owe Mr. A bx. You owe Mr. B bx. How many bx do you owe? 2bx. That is what minus 2bx is. Plus what? Plus x squared. Plus x squared. We can name this as our what? As our equation what? Equation 2, because we are dealing with the second right angled triangle. If you observe, one of my challenges is the size of my board. So I'm going to erase so that I can bring it up and then solve further. Remember, we have gotten our equation 1 from the second right angled triangle that we got from our scaling triangle. Now, if you look at this is gotten from triangle BDC. You understand? Now we are going to switch to what? Triangle ABD. You understand? In triangle what? This is a symbol for triangle, please. Triangle A or B, triangle AB, ABD. You understand? In triangle ABD, what do we have? Remember that we have A, B, and D. You understand? And then X here is the adjacent side. You understand? C is the hypotenuse in this case, and H here is the opposite side. So the square of our hypotenuse, which is C, will be equal to what? The square of H, you know, plus the square of what? X. the square of what? X. Yes, plus the square of x. Now, what are we going to do? We want to make h the subject of the formula. This is our equation 1, by the way. This is our equation 1. All right. This is our equation 1. Let us try to write, okay, we still have some spaces. So let's go. Now, what do? We want to make h the subject of the formula in this equation. So our h squared will be equals to what? C squared minus what? X squared. Sorry, I'm writing x squared, please. X squared. All right. At this point, what do? They have told us that the square of h is equal to the square of c, the square of c plus the square of x. So we are going to substitute, you understand, this, the value for h square. We are going to substitute it for our h square in equation 2. You understand? All right, let me try to write our equation 2 here so that we will not forget. Please, pardon me. My board is very, very small. Okay, we have a squared. A squared is equal to what? A squared is equals to h squared plus b squared minus what? 2bx 2bx plus what? X squared. You understand? That is our equation 2. Yes, that is our equation what? 2. Please don't forget, that is our equation 2. And they are telling us that we should substitute the value for h square into h square in our equation 2. All right. So we are going to erase this now so that we can solve it further. Now, where is our equation 2? Our equation 2 is a squared. A squared. How did we even get a squared? See, this is the second triangle. The square of hypotenuse side is equal to the sum of the adjacent side, you understand, plus the opposite side. That is how we got our equation 2. Now, so a square is equals to, now that our h square is equal to c square plus x square, anywhere we see h square, we are going to replace it with what? C square plus x square. So we're going to have, instead of writing h square, we are going to have c squared plus x squared, you understand, plus what? B squared minus 2bx plus what? X squared. Please look at what we did. Instead of writing h, since they have told us that our h square is equals to c square plus x square, whenever we see our h square, which is here, we replace it with what? C square plus x squared. Then we plug in the remaining now what do? What do we do right here? Sorry, we made a mistake here. This is supposed to be minus. Yes, this is supposed to be minus because x squared crossed the sign of equality. You understand? S square is crossing the sign of equality to meet c square. So this is supposed to be minus. Yeah, this is supposed to be minus. So our a squared will be equal to what? Remember, we have minus x squared plus x squared. These ones will go. You understand? So we are going to have c squared plus b squared. You understand? Minus 2bx. Yeah, this is what we have left. This is what we have left because minus x squared plus x squared will cancel each other. You owe somebody x squared and you have x squared. When you pay, what do you have? You have 0. So this is, let's label this as our equation 3, please. Yes, for clarity purpose, let's label this as our equation what? 3. Now, there is something we are going to do again. Yes, we are going to take the cos. You understand? We are going to take the cos of angle A. Remember, this is our angle A. We are going to take the cos, you understand, the cosine of our angle A in this triangle ABD. You understand? So how do we do that? Let us erase from here, please. Let us erase from here. Yes, we only leave our equation 3. Alright, we only leave our equation 3. Let's bring our equation 3 up. A squared is equals to what? C squared plus B squared, you understand, minus 2bx. Yeah, this is our equation 3. This is our equation 3. Now let us clean this so that we can work further. Alright, look at what we are trying to do. Remember this triangle here, when you are taking cos of A, you're taking cos of A, you know that cos theta in SOHCAHTOA, you know we are dealing with right angle right now, right angle triangle right now. So the cos of cos theta means adjacent over hypotenuse. So cos of A, you understand, cos A will be equals to what? Opposite all over what? Hypotenuse. Remember, if we place our theta here, that means x will become our opposite. And remember, C is our hypotenuse in the triangle ABD. So what do we have? X, which is the opposite side, divided by what? C, which is the hypotenuse side, in line with cos theta in our hypotenuse, in our what? SOHCAHTOA. You understand? SOHCAHTOA, whenever they talk about cos, they are talking about adjacent all over hypotenuse. If you observe, you can see that we have a fraction here. Cos A is divided by 1, x is divided by c. So what do? We are going to cross and multiply. You understand? We will cross and what? Multiply. So what do? 1 minus or 1 times x will give us x equal to what? Cos A multiplied by c will give us cos A what? C. You understand? Now this is the value for our x. So what are we going to do? In equation 3, we are going to replace cos AC. We are going to substitute cos AC for x. You understand? Anywhere we see x, we are going to put cos AC because they are telling us that x is equal to cos AC. So what do? Let's plug it into our equation. So our A squared will be equal to what? C squared plus what? B squared, yeah, minus 2b. Now, instead of writing x, what do? Cos what? AC. Because they say x is equal to cos AC. So instead of writing x, if they tell you that 2 plus 2 is equals to 4. Instead of writing 2 plus 2, you put your 4 because 2 plus 2 is the same as 4. They say x is the same as cos AC. So instead of putting x, we have put our cos AC right here from this equation. So what do? We can erase from here now. Yes, let us erase from here. Now, let us bring this up. Our A squared is equals to what? C squared plus what? B squared minus 2 b cos what? Cos A C. What are we going to do? We are going to rearrange. So our A squared will be equals to what? B, because B comes before C, you understand, plus C squared minus what? 2b. Let us put the C here. 2bc. We have brought this C here. You know, in multiplication, 2 plus 3 is the same as 3 plus 2. So even though C is everything here, as far as there is no minus or plus between these variables, they are multiplied. You understand? When you see C, D, X, Y, these are multiplications. And in multiplication, when you are multiplying numbers, it doesn't matter which one that comes first, you get the same result. Whether you multiply 10 by 4 or 4 by 10, you have the same answer. So we have decided to bring our C here. You understand? This C cos what? Cos A. You can see that we have generated our what? Our cosine formula. And mind you, there is something I want to explain. This is the standard cosine formula. But what becomes the subject of the formula depends on what you are looking for. When you are looking for side A, that is when A becomes the subject of the formula. When you are looking for side B, for example, you have B squared will be equal to what? The square of A plus the square of C minus 2 what? AC. You understand? Cos what? Cos B. You understand? When you are looking for side C, for example, you are going to have C squared is equal to what? A squared plus B squared minus 2AB cos what? Cos C. You understand? It depends on the side you are looking for. So in our next lesson, I'm going to explain how to manipulate this cosine formula. You understand? How it is the algebraic manipulation that is involved when you are looking for angle. All this now, A squared, B squared, you understand? C squared. These ones are applied when you are looking for, when it is side you are looking for. When you are looking for an angle, it is cos something, cos X. You understand? If it is cos A, cos B, or cos C. So when your cos something will be the subject of the formula, there is a manipulation that occurs. And I'm going to explain that in our next lesson so that we can understand the process. In our next lesson, we are going to bring a problem that requires the application of cosine formula. Now that we have understood how we derive cosine formula, I believe that when we want to apply it, it will be very easy for all of us to understand. Thank you very much for your attention.